Hello again. In the last lecture, we talked about lists, right? Which are which are data structures that store collections of data, right? Collections of data, and what they do is they store all these data under a common variable name. Common variable name. Okay. Uh, each of these individual data can be accessed using indices or indexes, accessed using indexes, right? And these indexes can be variables or expressions, which means the data can be accessed using a loop, right? And that makes list efficient when accessing or when storing large amounts of data, right? So this is used to store and process large amounts of data. Okay. Now we have seen how to create lists, right? We have seen how to create lists. We have seen different approaches of creating lists when all the data are known, or the data is unknown but the number is known, or when neither the number of items or the actual items are known, right? So we have seen how to create lists. We have seen how to alter lists. We have seen how to access list, right? So we have seen the fundamental operations that can be done on a list, right? Fundamental ops on lists. In this lecture, we'll talk about some more advanced operations. Okay, operations like creating a slice from a list, or sorting a list, okay, or find the minimum or maximum elements from a list, and so on and so forth. Okay. So the first thing we will talk about in this lecture is getting a range of elements from a list. Okay, essentially means a slice or a sublist Okay, a part of the list. Okay, and the general form of doing that is using the name of the list, right? The square bracket notations, right? And then 3 arguments. The first argument is the begin index, the second argument is the end index, and the third argument is the step. Okay. Now this formula, okay, or this syntax returns the sublist starting from position begin index. Okay, so that's this. Okay, starting from position begin index up to but not including your end index. Okay, up to but not including your end index. So let's say this is 5 and this is 10. You will get the list elements from 5 through 9. Okay, so 5, 6, 7, 8, and 9. Okay. Finally, the third argument step indicates the number of items to skip between items. Okay. So if the step size is 1, you choose every element. Okay. If the step size is 2, you choose every other element starting from begin index. Okay, so begin index would still be there, but then after that you choose every other element. Okay, if the step size is 3, again begin index will still be there, but then you choose every third element from there, right? Now the arguments begin index, end index, and step are optional. Okay, and we'll see the syntax of what to do when any of these are omitted. Okay, now if begin index is omitted, the sublist starting from position 0 up to but not including end index is returned. So if begin index is omitted, it is essentially considered to be 0. That's the default. Okay, that's the default. If the end index is omitted, the substring starting from position begin index until the end of the list is returned. So if begin index is omitted, it defaults to the length of the list. Okay, default to the length of the list, right? And if the step size omitted, it defaults to 1. Okay. Now, one minor but extremely important part of this syntax is the colons, okay, and they play a very important role. It turns out that one of these colons is mandatory, okay, and this is this one. This colon is mandatory, okay, and this, the second colon, is optional, okay. So what you can have is you can have a sublist. Let's say you have a list called grades, okay. You have a list called grades, okay. When you want to take the sublist, okay, you should have at least one column, okay. This would essentially mean the sublist starting from this is equivalent to grades starting from the first 0th element to whatever the list is, right? So len of grades, okay. So the first colon is optional, I'm sorry, mandatory. The second colon though is optional, okay. So in this example you have only one colon, which is the first one, okay. Now if you, in this case, we have omitted all three. We have omitted begin index, we have omitted end index, and we have omitted step. All three of these arguments have been omitted, but you still need this colon notation to sort of make it clear to Python that you're talking about a sublist, okay. Obviously it doesn't make any sense because this is equivalent to the original list itself, right? So you will never use this notation. It doesn't make any sense to use this notation, right? But just so you know, the first colon is mandatory, and when you have one colon, Python infers that you are talking about, when you have one colon, Python infers that you're talking about the first colon right here, okay. If you have one colon, Python infers that you're talking about the first mandatory colon, okay. Now why is this piece of information necessary? Because when you have two numbers separated by a colon, Python will always assume that you're talking about the begin index and an end index, okay. If you have a single colon separating two numbers, let's say 2 and 4, okay, Python will assume that 2 is the begin index and 4 is the end index. Now let's say you want to get a sublist from 0 to the length of grades, but with a step size of 2. What would you do? What you would do is you'd say grades colon and then a colon and then 2, okay. This is essentially equivalent to grades 0 to length of grades and 2, okay. So this will give you, this sublist will return the sublist of grades starting from index 0 all the way through the length of the grades, not including obviously, because if the length of grades is let's say 4, your indices are 0, 1, 2 and 3, right? And a step size of 2. So what you will have is, let's say you have a uh, grades, okay, a list of grades, let's say of size 8, okay, a list of grades of size 8, and the indices of the elements are 0, 1, 2, 3, 4, 5, 6 and 7, okay. And just to remind you, the length is 8, length equals 8, okay. So the second statement right here would give you, okay, elements 0, so this one, right, with a step size of 2. So the next element would be 2, 4, 6, right, and then it stops, okay, then it stops. Now let's say you want to get the elements from 0 through let's say 4 with a step size of 2. All you do is change this, change this to 5, okay, and that will give you elements 0, 2 and 4. Okay, now let's see a few examples of getting slices from a list. Okay, so in this small code snippet right here, we have this list called grades, which contains the elements b plus, a plus, a and c minus, right? So just to remind you that the indices are 0, 1, 2 and 3. The next statement returns or prints the sublist starting from begin index 1 and end index of 3. So this gets a sublist starting from index 1 and up to but not including 3, so 1 and 2, right? So it displays a plus, obviously there is no space, that's a mistake, no space, a plus and a. Okay, as I said before, when you have just a single colon, this is inferred to be the mandatory one, right? This is mandatory, which means Python infers or assumes that the first number is the begin index, right? And the last number is the end index, right? That's the end index. Okay, now the next list contains 6 elements. Okay, again the indices are 0, 1, 2, 3, 4, 5 and the length is 6, right? Now just so you understand this clearly, right, when you have a sublist, when you use this notation, what you get is it returns a new list. Okay, returns a new list, right? Now whatever you can do with this list, you can also do with this new sublist right here, right? So in this case, in the first example, we printed this list, right? This is where we printed this list. You can actually also choose to save this list as another list. Okay, you can choose to save this sublist as another list, which is what we do in the second example. Okay, so what we have is, given the list A, we get the sublist starting from begin index 2, so that's where we start with, that's the begin index. Okay, and up to but not including 4, so 2 and 3. Okay, and this 2 and 3, these two sublists are stored as a new list which we call B, and then we print B and this displays 60 and 72, right? Now again, because there is just one colon right here, Python assumes this one to be the mandatory one. This is the mandatory one, right? Which means the number to the left of this would be the begin index, which is 2. The number to the right would be the end index, which is 4, right? That's why it displays this. Now in the third example, we have again a list of grades. The indices are 0, 1, 2, 3, 4, 5, 6, 7 and 8. So the length of grades is 9, right? So length of grades is equal to 9. Okay, so when we do print grades 172, here obviously we have used both the two columns, right? This is the mandatory one, right, and this is the optional one. So this is sort of very close to the general form that we talked about. So this is the begin index, this is begin, right? This is the begin index, this is the end index, and this is the step size, right? Now what this says is display the sublist starting from begin index 1, so starting from here, right, ending at 7, so up to but not including 7. Okay, so up to here, right, but print every other element. So step size of 2. So the first one I'll print is this one, then I'll jump and then print this one, and then jump again and print this one, right? And then we would not print this though, because 7 is not included. This is not included, right? So we would not print 7. We could have printed 6, but because we have a step size of 2, right, that's where we stop. So this only displays a plus, which is this one. That's the first thing it displays. C minus, which is this one, and B minus, which is this one. Okay, and again, the space here is a mistake. There would be no space. Again, no space here. Okay, no space. So if you were to save this into a new list, right? If you were to save this into a new list, if you, let's say, if you said, I don't know, grades 1 equal to grades 1, 7, 2, this new list grades 1 would look like this. Grades 1 would just have 3 elements, okay, and the elements would be A plus, C minus, and B minus. Okay. Now, Python lets you do some pretty interesting stuff with the slice notation. Okay, and especially when the step size is negative. When the step size is negative. Okay. Now, what happens is when the step size is negative, the meanings of the syntax remains unchanged, but the defaults will change. Okay, so when the step size is negative, let's say when the step size was positive, right? The syntax was you had a list of grades, and then you had 3 arguments, right? The begin, right? The end, and the step, right? And when the step size is greater than 0, begin would default to 0, end would default to the length of the list, right? But if the step size is -1 or less than -1, so essentially less than 0, the default values will change. Okay, so if the step size is less than 0, what will happen is the beginning of the list will default to the length of list -1. That's your beginning. The end would default to -1. Okay, does it make sense? So we will start from the begin and go up to, but not including the end. So we will not go to -1, we'll go to 0, we'll go up to 0, right? We'll not go to -1. Okay, anyways, so end would mean the beginning of the loop, begin would mean the end of the loop, right? So let me make it simpler. Actually, let's not complicate things. When the step size is -1, when the step size is less than 0, actually, the begin would mean the end of the loop, right? The begin would default to end of the loop, and the end would default to the beginning of the loop. Beginning of the loop, right? Now let's see a few examples. Okay, so in the first example right here, we have a list of gods, right? The size of the list is 4, so list size is 4. The indexes are 0, 1, 2, and 3, right? And the name of the list is gods, right? So in the first statement right here, we print gods, and then we have omitted the begin and the end, and we just specify the step size of -1, right? So what will happen is this will default to the end of the loop, right? This will default to the end of the loop. I'm sorry, end of list, this will default to the beginning of list, and the step size is obviously -1. So this will give you a sublist which starts from the end of the list, right, which is Hermes. It starts from Hermes, goes all the way through the beginning of the list, which is Aries, and steps backwards. Okay, so it will give you Hermes and then Aphrodite, Hera, and Aries, right? So the final list or the sublist or whatever, right, would be Hermes, Aphrodite, Hera, and Aries, right? So essentially it has flipped, right? It's essentially the list has reversed. So this syntax right here, it's an easier way of doing, or it's a neat way of doing list reversal. Okay, list reversal. Remember when we started this, when we started talking about lists, the problem that we posed, okay, the premise, and it was that we have a list of students, right? We have a list of students, and we want to remember the names of the students, and then print them backwards, right? So the user will enter the name of students, and then we will print the names of students in the exact opposite way, right? So if we use this syntax right here, it would be just one small statement, right, to actually print the names in reverse. So this is a neat way of doing list reversal. As usual though, you can also save this list instead of printing it, right? So you would say like gods, you'll say gods reverse, I'll just say underscore rev rv, okay, equals, you could say gods colon colon -1, and that would mean the gods RV will be Hermes, Aphrodite, Hera, and Aries, right? Now also, as I said before, you can specify a begin index. Okay, in this next example right here, okay, we have specified a begin index. So that is begin, that's specified. Okay, that's the begin, I'll just say begin IDX. So that's the begin index, right? So we start at index 1, which is this one. We start at Hera. Okay, we started Hera, so that's what we print first. The end index is omitted, so it defaults to the beginning of the loop, right? So it defaults to the beginning of the loop. I'm sorry, beginning of the list. Okay, right? So it's here, somewhere in here. Okay, index -1 or something, right? So this statement, what it does is it prints the sublist starting from the first index, because this is index 1, all the way to the beginning of the list with a step size of -1. So it'll print Hera first, and then it'll print Aries, and then it'll stop, right? So Hera and Aries. Okay. Finally, the last syntax in the last statement, we specify both the begin and the end index, right? That's where we begin. That's where we end. Okay. And we say a step size of -1. That's our step size. Okay. Now this prints nothing. It will not print anything. Why? Because what you're saying is print starting from the first element, so print from Hera, right? Print all the way to the up to the second element, so till Aphrodite, but not including this, right? Up to but not including this, right? But go in the reverse direction from here. So if you do that, right, you will never reach Aphrodite. Okay, you'll never, if you start from index 1, you will never reach index 2 if you go backwards, right? You'll reach index 0 and -1 and so on, but you never reach index 2, which is why this prints nothing. Okay, empty list. Okay, so the idea is, if you want to use a negative index, you must be if you don't, and if you want to specify both these indices, the begin and the end one, you have to make sure that the begin index should be greater than the end index. Okay, that's the thing that you have to specify. You have to make sure if you want to specify both these indices. If not, Python will use defaults anyway. Okay, but if you want to specify the indices, you have to make sure that the begin index is larger than the end index, right? Now, another extremely important function that is often used with a list is the length of a list, okay? Getting the length of a list. And this is done by simply using this function called len, okay? This is already defined in Python. The len is a Python built-in function, built-in, okay, function, right? And just so you know, this function len can be used with other data structures as well. So it's not that you only want to get the length of a list. Okay? You can want to get the length of other data structures as well. So this len is sort of a generic function, okay? But in this case, we'll only talk about lists, of course. Now, in this example, what we have is a list of length. As we can see, the length is 6, right? Length is 6. So if you just print the length of B, it will output 6, right? Obvious, right? It's not a big deal. But this also works with your slice notation, right? So in this case, we have C equals B 2, 4. So remember, the indices are 0, 1, 2, 3, 4, 5, right? And when we say B 2, 4, it means starting from index 2 up to but not including 4. Okay, so which is this, right? So the new array C, the new list C is 60 and 72, right? 60 and 72. And when we print the length of C, it outputs 2. Okay. So the easiest way of finding the length is subtracting the end from the subtracting the begin from the end index. So 4 minus 2, right? 4 minus 2 is equal to 2, and that would be the output of the new list. By the way, you can also do things like this. You can also say, instead of saving this sublist in C, right? You can also say print len of B to 4, and it will give you the same result, okay? Because essentially this is, although it's a sublist notation, it is still a list in its own right. It is still a list, right? So it will give you the same result, okay? Now we'll see how we iterate through list, right? And by iterating, what I mean is going through every element, okay? Going through every element in a list. Going through each and every element in a list. Okay, that's what we mean by iterating. Now there are two approaches. The first one we will look at is using the index, okay? Using the indices approach, using this approach right here. So this is, I'll call this using list indices or indexes. I'll just say indexes, okay? So that's the first approach we'll see. Now in this example, we again have a list of Greek gods, okay? The indices are 0, 1, 2, 3, and 4, okay? So if we want to go through each of the elements in the list, let's say we want to print these elements, okay? Not much else, we just want to print them. What we do is, for I in range 5, okay? So remember this notation right here? For I in range 5, what it does is, it makes sure that the I takes values from 0 through 5, but not including 5, right? So it just says 0 through 4, right? So I is 0, I equals 0, and then 1, 2, 3, 4, and then it stops, right? So in this example, what we do is, we go through each of the elements in the list and we just print it. But you don't have to print it, you can do something else as well, okay? Completely up to you. But this lets you access each of the elements one by one. So essentially, access each of the elements, each of the items in the list one by one, okay? So in this case, we just print it, but you can do something else as well. So using a for loop and the number of elements in the list, which is in this case 5, okay? The list size is 5, list size equals 5. So for loop and range list size 5, we just access each of the elements by using I as the index, right? By using I as the index. Okay, so we talked about using variables as indices. Okay, using variable, using a variable as index, and the variable changes value every time in the loop, right? So initially the variable takes the value 0, right? I equals 0, and then it takes the value 1 and 2 and 3 and so on and so forth, right? So that's one way, and that's possibly the simplest way of iterating through each of the elements in a list. Now in this example, in the first example, we actually did nothing with the elements themselves, right? So you might be wondering, why do we need to go through all these if you can just say print gods, right? You can just say print gods, and that would give you the exact same result, right? Well, not exactly the same, because in this case each of the gods would be printed in a separate line. So it would be something like Zeus and Ares, the Hera, right? As opposed to using this statement right here, which will print gods in this format. It'll say within square brackets, it'll say Zeus, right, Ares, and so on and so forth, right? So this lets you access this statement right here, this not statement, block of statements, lets you access each of the elements individually. Okay, now in the second example though, we actually do stuff. We don't actually, here we do though. So we do stuff with the elements. Okay, so we have a list called B, which has 6 elements, right? Which has 6 elements, and the indices are, as you know by now, 0, 1, 2, 3, 4, and 5. Okay, these are the indices of the 6 elements. Now we print B, obviously, so it outputs the list. Now what we do is we want to multiply each element with itself. Okay, so what we do is for I in range, now this time using a hard-coded value of 6, we use the length of B, so you don't have to calculate manually every time, right? So we say for I in range length of B, do this. Okay, bi equals bi times 2. Okay, and then print B. So what happens here essentially is length of B is replaced by whatever the length of B is, right? And the length of B is, we know, is 6, right? So length of B is 6. So this changes to 6. Okay, so for I in range 6, bi equals bi times 2. So for I equals 0, when I equals 0, what we do is b0 equals b0 times 2, and this is b0, right? So b0 becomes b0 times 2, so it becomes 160, right? And then in the next iteration, I equals 1, so we say b1 equals b1 times 2, and this is 1, this is 65. So at this, we change this value to itself times 2, so this becomes 130, right? And then I becomes 2, right? And then this changes to b2 equals b2 times 2, right? This is b2 equals b2 times 2, and as we know, b2 is this element right here, so this becomes 120. Okay, and it goes on and on. So I equals 3, this value is, this is the third, right? This is 72 times 72, which is 144, and then I equals 4, this is 4, 30 times 30, which is 30 times 2, which is 60, and then I equals 5, right, which is the fifth element, which is right here, and 40 times 2, that's 80, and that's when it stops, right? So using this syntax right here, we can actually modify, we can not only read but also modify, read, modify each of the individual values in a list. Now there is another approach of iterating through a list in which you just want to read the numbers and not modify. Okay, just want to do something with it but not modify the original list. Okay, and that is using this approach. Okay, and here we do not need to specify the length, or we do not have to have a separate variable, right, for the indexes, and we do not have to access each of the elements by their index. Okay, and the format is this. Okay, so we have a list of grades. Again, the indices are 0, 1, 2, and 3, but we don't care. Okay, we don't care what the indices are, we don't care what the length of the grades is. Okay, we don't care. But Python will let you do this, okay? It will let you say, for every grade in grades, print grade, okay? This is in English. If you translate this statement in English, what you're saying is, for every grade in the list of grades, right, print grade. That's the English version, okay, translated to English, okay? And what happens is, if you see word by word, right, it actually is very intuitive, okay? So what you're saying here is, for that's for every grade, so this is grade, this is every grade, okay, in sorry, this would be in, right, for every grade in, and then you have grades, which is the list of grades, right, the list of grades, right? So for every grade in the list of grades, print grade, plain English, right, nothing more, okay? So to simplify, for every grade in the list of grades, print grade. So in this case, we did not use indexes, right? Secondly, did not care about length. All we told Python was, for every grade in the grade, and Python will understand, okay, I'm talking about for I equals 0 through the list of grades, right? And we don't have to specify each of the indices. Python will take care of that, okay? Python will first print this one, and then this one, and then this one, in this order, okay, in this order. So it will first print index 0 and 1 and 2 and 3, okay? And we don't have to specify the length. So Python will know that it will start from the first one and end at the last index. That's it, okay? So this is a much simpler way of iterating through each of the elements of a list. But you need to remember this, okay? This is a read-only approach. This is a read-only approach, okay? Unlike the previous one, which was read-modify, this is read-only. This only part is important, okay? You can read, but you cannot modify, okay? So in this example, what we have is a list of numbers, 5, 10, 3, and 2, okay? And we print the numbers. The output is 5, 10, 3, and 2, obviously, okay? And now what we say is, for every number in numbers, number times equals 2, okay? And then we say print numbers, okay? And when we output, we might expect that all these numbers would be multiplied by themselves. So this would become 10, this would become 20, this would become 6, and this would become 4, right? But that's not the case. If you see the original list, the list before you did this operation, and the list after are or is the same, okay? They have the same elements. So this is a read-only approach. When you get this number, right, it's a copy. This is important, okay? When you get this variable right here, it's a copy of the actual number. Okay? So you do not have direct access to the list element. All you have is you have access to a copy of that element. So if I were to change this code, if I were to make this code equivalent to the previous approach, to this approach, right, what I would do is I would write this, okay? So this code is equivalent to writing this: for I in range len of numbers, right? For I in range len of numbers, I'd say number equals numbers I, and then we say number star equals 2. So number equals number times 2. Number equals number times 2, right? So what's happening here is, I sort of create a temporary variable called number inside the loop, right? And this temporary variable number contains a copy of the value. It does not refer to the actual variable. it contains a copy of the value. So whatever changes I make to this copy, and these changes that I made would be lost when I go back at the end of the loop, right? So all the changes would be lost. So no matter what changes you made, they were made to the temporary variable. So number is a temporary variable, okay? Temporary variable. So whatever changes you made to this number would only be applied to this variable and not the actual list, okay? And all those changes would be lost when you go here, right? So now that we have gone through a lot of the operations that you can do with lists, let's see a few examples of using lists and solving problems with lists, problems specific to lists, okay? So we start with the first example right here, which says write a Python program that creates a list with the following values. Okay, the values are given, okay, and then calculates and displays their sum. Okay, calculates and displays the sum. Okay. So since we know the values beforehand, right? All the values are known. We can just use this syntax to create the list, which is just create the list with the values, right? That's simple. We do not have to say values equals none times whatever, right? Or we would not say values equals an empty list and then keep on appending. We can do that. It's perfectly okay. But it's not necessary, okay? Since we already know the values, okay? These are the values: 56, 12, 33, 8, 3, 2, 9, 8. So we create a list using these values, right? So the first solution is, and remember we want to calculate the sum, calculate and display the sum, right? The sum of the elements. So the first solution is using the read modify approach that we saw, the read modify approach, in which we use an index, a variable for the index, and the variable is updated inside a loop, right? We use a variable and that's updated inside the loop, right? So in this case we are using that, okay? So we create a temporary variable to store the sum, temporary variable, right? Temp variable to store the sum, okay? And remember, every time we calculate things in a loop, we always start with a temporary variable that will, by the end of the loop, store the final result, right? This temporary variable will store the final result at the end. That's the formula of calculating things in a loop, right? So this temporary variable would be updated every time inside the loop, and at the end of the iteration it will store the final result. So what the initial value of the temporary variable is and how we update that variable would be based on what we want to do, right? What we want to calculate. So in this case we want to calculate the sum, and when we calculate the sum, the initial value is always 0, right? So what we do is, for I in range of length of values, whatever the length is. So in this case the length is 1, 2, 3, 4, 5, 6, 7, right? So this len values, this function right here, would be replaced by the actual length, which is 7, right? So essentially this means for I in range 7, which means 0 through 6, right, total equals values I, okay? So at the end of the first iteration, total would be 56, right? Because values I, so total would be total plus values I, and I, remember, is 0. So total equals total plus value 0. So what is total? This is value 0, right? This is index 0, and total was 0, right? Total was 0, and value 0 is 56, so this would be replaced by 56. So the new value of total equals 56. Okay, that's our new value of total, 56. Okay, now in the second iteration, right, for I equals 2, you again say total equals total plus values I, where I equals 2, right? So I equals 1, which is this one. Total equals total plus values I. So total equals 56, right? So total equals 56 plus value is 1, which is 12, right? So 56 plus 12. So the new total is 56 plus 12 is 68, right? 68. So that's the new value of total. And then you go back to this loop, right? You do this again, but this time I has become 2, right? It was 1, now it's 2. So you say total equals total plus values 2, right? So total equals the previous value, which is 68, plus values 2, which is 33, right? And so on and on it goes. So by the end of this, at the end of this loop, by the time you're done with this loop, total, right? Total will start with 0, and then will contain 56, and then 56 plus 12, right? And then whatever the value of this is, 68 plus 33, and then this is uh, 68 plus 33, which was 90, 98, 101 plus 8, right? So that's 109, 109 plus 3, and so on and so forth. So by the time you are done with this loop, total will contain the sum of all these values, right? Then all you do is print it, right? So that's the first solution using indexes, using this read modify. Now the second solution is the read only. That's the read only solution, okay? Read only. And this perfectly works because we are not actually modifying the values, right? All we do is we take each of these individual values and add them up. So we don't really modify them. So we are okay with using the read only, right? So in the read only, it's pretty similar to the previous one. Again, we start with a temporary variable, total equals 0. But now, instead of for I in range, blah, 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 we just say for v in values. So this means for every v in values, okay, you can also say for every value, that's a name of variable, so it doesn't matter what you take, right? So for every v in the list of values, total equals total plus v, exact same thing, right? Underneath it does, under the hood it does the exact same thing, okay? But it's I think it's a neater way of representing this, because it makes sure that you cannot modify the values, right? It sort of, even if you look at the program, it suggests that you cannot modify the value. This is a better way of dealing with things if you want a read-only approach, right? So all we do is for v in values, so for every value in the list of values, add it to the total. So the total starts with 0, total starts with 0, right? And then for every value in the list of values, add v to the total. So the first time that the loop runs, it will add 56. The second time it runs, it will add 12. The third time it runs, it will add 33, right? And so on and so forth, until it adds the last one, which is 98. And at that point, it stops because there are no more values. There are no more values left in the list of values, right? In this next example, we are asked to write a program that stores the names and the marks of 5 students entered by the user, okay? Now, again, remember when we talked about lists, we said that if we have different types of data, it's okay. I mean, it's a good idea to create different lists for the types of data, right? So we have 2 lists, one for names and one for marks, right? Each of size 5, right? So I say I create a new variable count and assign it the value 5. So that's our size. That's the size of both lists, right? Of both lists. Okay. Now, because we don't know what the values are, it's a good idea to create the empty list, right? So this essentially what this does is allocate memory to store the lists. It's a good idea, okay? It's efficient to pre-allocate memory. You can also go for the empty list approach and then use the append function to keep appending data to the list. But what happens if you do it is the list grows in size, and every time the list grows, the computer has to allocate memory to the RAM, and that is slow, okay? So if you can pre-allocate, it's always a good idea to do so, right? So count is 5, and then we pre-allocate the memory using the none times count, right? And then we create a loop, right? And remember, we cannot use the read only, right? We have to use the read modify because we are actually modifying the list, right? We're actually modifying the list, so we cannot use read only. Okay, so what happens here is, inside the loop we say names I equals input enter name, okay, marks I equals int input enter marks, and that's it. Simple, right? So for each of the names we ask the user for the name, and for each of the marks we ask the user for the marks, and store and save it as an integer, and then at the end of this program we print the names and the marks. Okay, and if you remember our previous discussion, uh, the names and marks, if you juxtapose the names and marks, they will belong to the same student, right? So you have two lists, names equals to a list of size 5, right? And you have another list called marks, which is again a list of size 5. So if you juxtapose one of these lists, right, let's say this one, okay, this is index 0, 1, 2, 3, 4. This is also 0, 1, 2, 3, 4. So the items at the same index would sort of belong to the same student. Okay, so if you want to, let's say, get the names and marks of students of student number 3, let's say this is the ID, okay, student ID 3, just go here. Okay, that's the name, and that's the marks obtained by student number 3, as student ID 3, right? Okay, now as I said before, if you don't want to pre-allocate space, it's completely okay. I mean, computer is fast anyways, you'll barely notice a difference. Okay, and it's okay to do so. It's not a big deal, honestly. So if you want to do that, you can use this approach. Okay, so instead of using something like this, names I and marks I equals, instead of using the assignment, remember this is the assignment operator, assignment, right? Instead of using the assignment operator, you can use the append function to append to the list. Okay, so in this example, both names and marks are empty lists. So names equals nothing, marks equals nothing, but you just stated to Python that these are lists. Okay, these are, right now they're empty, but these are lists. So for I in range count, which is 5, so for every time in I is 0, 1, 2, 3, 4, names dot append, right, and then whatever the name that the user provides, and marks dot append whatever the marks the user provides, converted to an integer, right? So let's say initially names and marks are 0. After the first iteration, the user provides the name to be like Alice, right? So the names would contain one element, Alice, right? And it will contain the marks of Alice, let's say 70. So at the end of the first iteration, names and marks would be lists of size 1. Okay, at the end of first iteration, they would be lists of size 1. Okay, now at the end of the second iteration, again, you entered a name, you entered a marks, so the list would be of size 2. So in this case, it would be, let's say, Alice and Bob, right? And the marks would be 70 and 80, let's say. Okay, so at the end of the second iteration, it will both names and marks would be lists of size 2, right? So this is another approach of doing it. Okay, it's more or less the same, except I would say that the first one is a more efficient option of doing so, because you pre-allocate the memory. It would be ever so slightly faster. Okay, and again, for 5 elements, it doesn't make any difference whatsoever. But if you had 5 million elements, then it would make a difference. Okay, maybe even not that. Okay, if you go for 5 billion elements, then it would definitely make a difference. Okay, so if you know the number of elements beforehand, it's definitely a good idea to pre-allocate. Okay, to pre-allocate by saying that, okay, I need a list of this size. Okay, give me an empty list of this size, and that definitely helps with the efficiency. But again, doesn't really matter. I mean, hardly matters when the count is 5. Okay, Even if the count is in millions, it probably won't matter much, but it will start to matter when it becomes like hundreds of millions and billions and so on and so forth, right? Now in this next program, what it suggests doing is it lets the user enter 20 words and then it displays them in the exact reverse of the order in which they were given. Okay, so this is where lists really come in, right? So in the previous two examples, if you think about it, right, uh, probably you don't need lists for these, right? You don't need to save because all you're doing is printing, right? And even in the previous example, you're just getting the sum of these numbers, right? So you don't really need lists for that, okay? Because if you remember, we had examples like this before, even before we learned doing lists, right? So for these examples, we don't really need lists, but for the next one, okay, reverse order, you need to save them, you need to remember them so that you know what the exact reverse is, right? And this is the premise. This is where we began talking about lists, right? So as usual, because we have 20 words, it's a good idea to reserve 20 locations in RAM, okay? Reserve 20 locations in main memory. And we do that using the none times 20 syntax, right? Now we can use the read only approach, right? We can use the read only approach. No, sorry, I'm sorry. We can't. We have to use a read modify approach because we're actually storing, right? We are storing. So this is assignment. So we are actually modifying the list. So we have to use the read modify approach of iterating through the lists, right? Anyways, so we say for I in range 20, right? Again, we know this is the length of the list. We know this beforehand. All we do is words I equals input. So for each of these, for each iteration in the loop, I will change values. It will start from 0 and then 1, 2, 3, so on and so forth. It will go all the way up to 19, right? And for each of these different values of I, we will store words given by the user. So input, I'm sorry, just input. This will be the word that has been provided by the user, right? So at the end of this point, we have our list, okay? List is ready. The list will contain all the words by this time, okay? The next thing we do is we can use this formula right here for I in range 19 minus 1 minus 1, okay? 19 is the starting point, is the begin index, minus 1 is the end index, okay, end index, and minus 1 is the step size. So this says for I in range beginning from 19, right, up to but not including minus 1, obviously, because minus 1 does not exist. It does, but forget about it, okay? Up to but not including minus 1, and with a step size of minus 1, print words I. So this will print the words in the exact reverse order, okay? But you may have figured this out. This is not really useful for us. I mean, it's useful obviously, but it's not required. It's overkill because we already have this notation right here, okay? This rather nice notation with a negative step size, right? With a negative step size. The negative step size. And all we can do is for W in words, I'm sorry, there would be a tab, right? So this would be print W with a tab. For W, for each W in the list of words, but taken in the reverse order, okay? So no begin index, no default begin index, default end index, and a step size of minus 1, okay? So for W in words, in the list of words with a step size of minus 1, print W, and this will print each of the individual word in the list in the reverse order, right? Now here's another example which is slightly more convoluted, okay? So write a program that lets the user enter 100 numbers, okay, and then displays only the positive ones in the reverse order in which they were entered, right? So again, as usual, we know that the list size is 100, so why not just go ahead and pre-allocate memory, right? So count is 100, values equals none times count, so that's pre-allocating uh, an array, a list of size 100, right? And then we get each of these values, we let the user enter the floats, right? Enter the values. So for I in range count, uh, excuse me, values I equals float input, right? So here the user enters the value and then we convert it to a float and save it in the values list, right? So as usual, as you know by now, for I will take the numbers 0 through 99, right? And for every value of I, we make sure that the user enters an actual value and then we convert it to a float and then save it into the appropriate index inside the list. Okay, so by the time we are done at this point, we will have the list ready. The list would be ready, right? The list is ready, right? So the next thing we do is, for each of the we need to display the positive numbers in the reverse order. So what we will do is, we'll actually do the other way around. We'll go through the reverse order and print only if the numbers are positive. Okay, so the way we traverse the list in the reverse order is as follows. We say for every value in the list of values in the reverse order, so that's a step size of -1, if value is greater than 0, print value. Simple, right? So for every element in the list in the reverse order, get the value, right? Check if the value is greater than 0, and if it is, print value. Simple, right? The next example is also simple. So it says write a Python program that prompts the user to enter 100 numeric values, 100 numbers in a list, and then displays the elements with odd numbered indexes. Okay, so indexes 1, 3, 5, 7, and so on. Okay, so as usual, we say count equals 100 and then allocate values for 100 variables, 100 size list, and then for I in range count, values I equals float input enter value. So at this point, the list is ready. The list is ready to go, right? So the list has been pre-allocated and we have let the user enter values and save those values in the list, right? So how do we display the elements with an odd numbered index? The simplest way to do it is, for I in range count, so for every I from starting from 0 all the way through 99, including 99, if I modulo 2 is not equal to 0, this is how you get odd, right? Odd numbers. So for every odd number, such as 1, 2, 1, 3, 5, 7, so on and so forth, if you divide it by 2, you'll get a remainder, right? Divided by 2, you'll get a remainder of 1, always, right? So if I modulo 2, you could also say is equal to 1, right? So this is, you could also say if I modulo 2 is equal to 1, then you print the value, right? Because if you divide the number by 2 and it gives a remainder of 1, it would mean that the value must be odd, right? So that's one way of doing it. Okay, so you go through each of the elements in loop and then you check the index I, check if the index I is less than it gives a remainder of 0, gives a remainder of 1 if divided by 2 or not. Okay, and if it does so, you just print the value, else you don't print it, right? Else you do nothing, right? So else essentially do nothing, right? So if it's an odd index, it will print. If it's an even index, it'll do nothing. That's it. Okay, that's how you do it. The other the more Pythonic, this is the word. Okay, this is actually a word, Pythonic. If you search in the internet for you'll find questions like Pythonic way of doing things. So the more Pythonic way of doing this thing would be, sorry, not even this one. The more Pythonic thing would be this one. Okay, so for v in values 1, right, then an empty. This is the default. So this is end index. End index is defaults to because the size of the list is 100, right? End index will default to 100. Okay, so for for v in values 1 through 100 in steps of 2, print v. So this will start with the value at index 1. So it will print index 1 and then every other element, every other index, right? So 1 and then 3, skip 2 and go to 3, skip 4 and go to 5, skip 6 and go to 7, so on and so forth until it reaches 99. Okay, this is odd, at which point it will stop, right? But again, the non-Pythonic way of doing things would be to, for I in range 1, that's the starting index, count, that's the end index, and steps of 2. Okay, print values I. So you might have already noticed this, but this range syntax and the sublist syntax right here are actually really similar. Okay, these are really similar. Sorry, what I mean is this one, the range and the sublist. These syntaxes are really similar, except in case of sublists, you can omit the second argument, which then defaults to count. In this case, you cannot omit it, so because you have to specify how much do you want your range to go to, right? But essentially, all three of these methods, they achieve the same thing. I would say that this is the most Pythonic way of doing things. It is what you would it is the most neat way of doing things. Okay, so if you have to take any of these, like if you have to prefer any of these, I would prefer this one. Okay, so for every value v in the sublist of values starting from the begin index 1, end index is count, which is 100, and a step size of 2, print v. Okay, in this final example, we want you to write a Python program that lets the user enter 100 integers into a list and then display any even values that are stored in odd number index positions. Okay, so just listen to this carefully. Okay, go through this carefully. So given this list of, let's say, not 100 but let's say 8, right? Let's say we have a list of size 8, or yeah, sure, 8 is fine. So given this list of size 8, and the indices are 0, 1, 2, 3, 4, 5, 6, and 7. So we only want to display even values that are stored in odd numbered index positions. So what are the odd numbered index positions? It's this one, 1, 3, 5, and 7, right? So for each of these odd numbered index positions, if the value is even, we will display it. Okay, so as usual, we start by declaring the size of the list, allocating the memory, and asking the user to enter the numbers and converting that number to an int, and then saving that number into the list, into the specified index in the list, right? So by the time we are done with this loop, the list would be populated, right? So the first method is as we talked about, uh, using the for loop and the range function. Okay, so for I in range 1, that's the begin index, start from 1, begin index, all the way through count. So count is, remember, 100. So 1 through 100 in the steps of 2. So 1 and then skip 1, skip 2 and go to 3, skip 4 and go to 5. So it's just 1, 3, 5, 7, ... all the way through 99, because we don't go to 100, right? Anyways, so for I in range 1 through count, which is 100 in steps of 2, if the value is even, which means the value divided by 2 gives a remainder of 0, right? That's what even numbers are, right? Any even number, let's say 2, 4, 6, right? So on and so forth. Every even number when divided by 2 will give 0 remainder, right? And that's how you find if the number is even, right? So if the number is even, which means the values I, which is the value at index I, when divided by 2 gives a remainder of 0, we print the value. Okay, so for every even position, which is 1, 1, 3, 5, 7, and so on and so forth, if the value itself is even, then we print it, right? As usual, there is a more Pythonic way of doing things, right? Again, because we are not modifying the individual values, we just printing it, right? So we can also use the read-only approach. Okay, and the read-only approach is for every value v in the list of values or in the sublist of values, starting from the first value, right, to the last value in steps of 2, if the value is even, print the value. Okay, essentially the second method is completely and exactly equivalent to the first method, except it is a more Pythonic way. It is a more Pythonic way of doing things. Okay, more Pythonic. Okay, so what it does is it uses the read modify approach. It creates a sublist from the list of values, and the sublist is starting from the first index in the list, so skipping 0, starting from the first one, right, which means essentially the second one, right, and then take every other element, step size of 2, all the way to the end index, excuse me, all the way to the end, right? And for every such value, every value in the sublist, if the value itself is when divided by 2 give the remainder of 0, then you print the value. Okay? Otherwise you don't. Else, this means else do nothing, right? So this would be the end of this lecture. In the next one, we will talk about some more useful list functions such as min, max, and average, and sum, and so on and so forth. Things that we have been using, you have been performing by iterating through the loops. We'll see that some of these operations already exist in Python. Okay, so we'll go through such a list of useful functions. But till then, have a good one.